Alright, here's a quick refresher on distance, displacement, and how it relates to speed and velocity. First of all, distance is the total motion of an object. It's how far you walked, it's how far the car has traveled, it's how far the object has moved. It's always a total. Displacement is a straight line distance between the starting and ending position. So basically, it's how far away from the starting position the object is. Now, if objects move in a straight line in a single direction, distance and displacement will be the same. If there's any change in direction anywhere along the way, distance and displacement will be different. If they are different, then distance will end up being greater, displacement will end up being smaller. So let's take a little look here at some examples and get a feel with real numbers for how this works. Boy walks from point A to point C, then back to point A. The walk takes 15 seconds. We're going to find the distance, displacement, speed, and velocity. First, the distance and displacement. We want to look at each component separately. So we'll start with the A to C part, from here to here. Our person is moving to the right, and he's gone 10 plus 10, 20 meters. Now let's take a look at the C to A component. He goes from here all the way back to here. That motion is to the left, and again it's 10 plus 10 for a total of 20 meters. Let's do that distance and displacement calculation. Distance is again the total. So it would be 20 plus 20, adding our two vectors together for a total of 40 meters. Our displacement, on the other hand, is going to be quite different. We talked about these vectors as little arrows. We said if they're in the same direction, we're going to add them together. If they're in the opposite direction, we're going to subtract them. We have one to the right, one to the left, so we have to subtract them. 20 minus 20, our displacement is 0 meters. Now, displacement would have a direction on it, but since we haven't really moved anywhere, there's no direction that we can stick on this displacement. We just say it's 0 meters. Now let's move on to the speed and velocity idea. They both have the same looking equation. It's d over t. What makes them different is what d means. For the speed equation, d is distance. So we want to calculate the speed of the boy in this little trip. We would take his distance, which was 40 meters, and we would divide it by his time, which is up here in the original question, 15 seconds. 40 divided by 15 is 2.6 repeating. Now again, we don't use these repeating numbers in science. There's rules for rounding that you'll learn later on in your high school education. I'm just going to round this to the 10th place. And we had some issues with that in class. It's 2 point something. Well, because my 6 is followed by another 6, I will round it up to a 7. Anytime a number is followed by something 5 or greater, we round it up. 4 or less, we leave it alone. So we round that up to a 7. The unit would be what we see in the equation here, meters over seconds, or meters per second. Now let's do our velocity. The d in velocity is displacement, so we're going to have to use the 0 meters. So it ends up being 0 meters over 15 seconds. 0 divided by 15. Surprise, surprise. Is 0 meters per second. Now normally, again, a velocity would have a direction on it, but since we didn't go anywhere, there is no real direction. So you might be saying, how could it be 0? Again, displacement is your distance from your starting position. We started at A, we ended at A. We did a lot of moving, but we didn't go anywhere. Let's change it up to something that is actually going to have a velocity. Clear this out. Let's get rid of this. And this. And let's change the question to this, from point A to point B, then on to point C. Let's calculate it out this time and see what we got. And again, we'll start with our distance and our displacement. And again, each part separately. So A to B is what we'll do first. So A to B is from here to here. The direction is to the right, and we've gone 10 meters. Now let's do the second part. From B on to C. From here on to here. Again, our motion is to the right, and again, 10 meters. Now let's use those vectors to calculate our distance and our displacement. Again, the distance is the total, so I'm just going to do 10 plus 10. We've gone 20 meters. Now let's do our displacement math. If the vectors are in the same direction, to the right, we're going to add them together. So it's 10 plus 10. Our displacement is 20 meters. Whoa, how do we get the same number? Well, the reason we got the same number is because we moved in a single direction in a straight line from here to there. If an object is moving in a straight line and in a single direction, the distance and the displacement will be the same. That means when we go to calculate it, we're going to end up with the same numbers for speed and velocity. Our speed is 20 meters over 15 seconds, and 20 divided by 15 is 1.3 repeating. And again, I'm going to round that because scientists generally don't use these long repeating numbers. Something you'll learn about later in your education called significant figures. We can't do that. So for now, I'm just going to round kind of like you would round. We're going to round it to the tenths place. I wish this actually worked. I'm using my touch screen, and my touch screen is a little bit weird, and it's not very consistent. So 1.3, I want to make sure you knew that was a decimal point. Let's do the velocity. 20 meters again because it's the same number. Over 15 seconds is again going to be 1.3 meters per second. Now we do need a direction on this. All of our motion was to the right. We ended up to the right, just 1.3 meters per second right. Let's do one now where the distance and displacement will end up being two different numbers. So let's get our boy back to point A. Let's get rid of this. Let's get rid of this. Now let's change this from A to C, then back to B. And let's work out our math this time. And again, we'll look at each part separately. From A to C first. So from point A to point C, we've gone to the right. It's 10 plus 10, 20 meters. Now we're going to go from C to B, from here to here. That is motion to the left, and it is 10 meters. Do that distance displacement math. Again, distance is the total. So it's 20 plus 10, 30 meters. Now let's do our displacement. Again, if the arrows, if the vectors are in opposite directions, we're going to subtract them. 20 minus 10 is 10 meters. Now direction is a little bit more challenging this time because it's not all in one motion. So we can either look down here at our number line. We started here over to A, we ended up to the right. Or we can look at our two vectors. The longer one's going to dictate your direction. So it's 10 meters right. Let's move on to our speed and velocity. Again, it's d over t. Speed is based on distance, the 30 meters. So 30 meters over our 15 seconds. 2 meters per second this time. For our velocity, it's going to be our displacement. 10 meters over 15 seconds. 0.6 repeating. Again, we don't like all that repeating nonsense in science. Because this 6 is followed by another 6, we're going to round it up to a 7. And again, because it's velocity, we need a direction. It's going to be to the right. Now note, the speed was greater than the velocity, and that's the way it's generally going to work out. And that's because when they're not the same, distance is always larger than displacement.